Hello everybody. I, Neetu Mane N, faculty from EEE Department of Sai Vidya Institute of Technology, welcome you all to the Basic Electrical Engineering Laboratory of First Year Engineering course. In today's session, let us learn about Experiment 4, Determination of Phase and Line Quantities in Star Phase, Three-Phase Star and Delta Connected Loads. The aim of this experiment is to determine the relationship between line and phase voltages and currents in both star and delta connected loads. The apparatus required to conduct this experiment are measuring instruments such as AC voltmeters, 2 in number, ranging between 0 to 600 volts, 2 ammeters, AC ammeters, ranging between 0 to 2 amperes, and 6 lamps. In a three-phased balanced system, the three voltages are equal in magnitude and the frequency, but they are displaced by 120-degree angles apart. There are mainly two types of connecting loads in three-phase system. They are star connection and delta connection. Now let us understand what a star and delta connection is. The star connection is formed by connecting starting or terminating ends of all the three windings together at a point. This common point is called neutral point. The remaining three ends are brought out for the supply connection. Star connection is preferred for long distance power transmission because it is having a neutral point. In star connection, the line voltage is √3 times the phase voltage, whereas the line current is equal to phase current. The line voltage is indicated as VL and the phase voltage is indicated as VPH. The line current is indicated as IL and the phase current is indicated as IPH. Next is the delta connection. The delta connection is formed by connecting terminating end of one winding to the starting end of the other, and the connections are continued to form a closed loop. The supply terminals are taken out from the three junction points. Delta connection is preferred for short distance power transmission. In delta connection, the line current is √3 times the phase current and the line voltage is equal to phase voltage. In a three-phase AC input, we have three terminals. They are R, Y and B, indicated with a color difference, that is red terminal, yellow terminal and blue terminal. So each current from R phase will be fed to a R load, next to a Y load and B load. So that is R phase, Y phase and B phase. The entry of the current IR will be considered as start of R phase, and the point at which the current exits will be considered as finish of R. Similarly, start of Y phase, end of Y phase, that is finish of Y. Start of blue phase and end of blue phase, that is finish of F of B. So the phase currents are indicated as IR, IY and IB. The line currents between the terminals RYB are indicated as IRY, IYB and IBR respectively. The phase voltages, that means the voltage that is measured between start of R and finish of R, that is any phase, start of one and finish of another, finish of the same terminal is called as a phase voltage, and that is indicated as VR, VY, VB. The line voltages are, that is the voltages measured between R, Y and B terminal at the input is indicated as VRY, VYB and VBR. So this is a star connection where we already learnt that three loads will come at a point. So this is R phase, Y phase and B phase. The current entry point is considered as SR, the exit point is considered as FR. Similarly is SY and FY, SB and FB. The star connection is where the similar ends meet at a point. Either it will be finish of a phase or start of a phase. Either can be done. And the point at which all these meet, that is FR, FY and FB meet, are called as neutral points. Similarly, the relationship between the voltage and current in a star connection, between the line voltage and phase voltage in a star connection, is given as VL is equal to root 3 times VPH, IL is equal to IPH. Next comes the delta connection, in which we see that the start of R phase, finish of R phase, this is one phase. The finish of R phase is connected to start of B. Then finish of B is connected to start of Y. Then finish of Y is again connected to start of R. So we see that there is a loop form. This is a closed loop. And here we can notice that dissimilar ends are meeting at a point. Right? Next, let us know about the voltage and the line voltage and phase voltage, line current and phase current relationship in delta connection. Theoretically, we all have learned it, where the line voltage will be equal to the phase voltage, whereas the line current will be root 3 times the phase current. Now that we have learned what is a star connected load and what is a delta connected load, and the theoretical equations in line voltage, phase voltage, line current and phase current, let us learn how the circuit is made of, and then let us learn how to connect the circuit practically. So first let us start with star connected load. So we know it is a 3-phase supply, so 3-phase AC input supply, which has 415 volts and 50 hertz. So between RY we have 415 volts, between YB we have 415 volts, and again when we measure the voltage between B and R, we will have 415 volts. And there is a TPSD switch to control its operation. And then the whole of this is a star connection. We have learned it just a few seconds ago. And we have connected ammeters, 2 AC ammeters and 2 voltmeters here. Why? Let us know why. We all know that current is, the ammeters are always connected in series where we need to measure the current. So we are measuring the current at this point, and that is the line current. Now, once the current enters the phase, right? So this is R phase, isn't it? This is Y phase and this is B phase. Once the current enters R phase, we are using an ammeter again to measure the phase current. And here we have considered lamps as loads in place of resistors, because these lamps are equivalent to resistive loads. So we have used 6 lamps, 2 lamps in each load to balance the circuit. And then the point at which all of them meet is the neutral point. Now, this voltmeter VL is measured across the line supply R and Y. So this VL records the voltage VRY actually. And then we have connected another voltmeter across the start and finish of blue terminal, that is the blue phase, and that records the phase voltage of blue. Since this is a balanced circuit, VR will be same as VY, VY will be same as VB. So VR is equal to VY is equal to VB. They are balanced circuits. Now let us learn how to conduct the experiment practically. As seen in the circuit diagram, the input is a 3-phase AC input supply with 415 volts, 50 hertz frequency. So these are the 3 terminals R, Y and B. So the terminals are indicated as R, Y and B. The color difference is indicated for the ease of our understanding. Then TPST. This is called triple pole single throw switch. That means a switch. So this is that switch, TPST. This is a switch which operates with a movement of one switch. Please observe, just by moving one, I can operate all the 3 switches. So hence the name triple pole single throw switch. And this is a fuse. every, as a protective measurement, every line will have a fuse internally connected. So that is all for the, because we are dealing with high voltage. 415 volts is a high voltage than normal. Usually we deal with 230 volts in a single phase supply, and here we are dealing with 3-phase voltage, and hence 415 is greater, right? So 415 voltage is greater than 230 volts, and hence it is higher. Now let us see that in the circuit, if you come forward, we are using measuring instruments such as ammeter, AC ammeters, and voltmeters, VL and VPH. They are indicated by VL and VPH. So let us know. So now let us learn about the measuring instruments, AC ammeter and AC voltmeter. So this is the device which is indicated as A. A means the device which measures current. The unit of current is amperes, and hence this is a ammeter. And AC is indicated like this, right? This is of the range 0 to 5 amps, and it comes with 2 terminals. All right. Next, let us learn about a voltmeter. This is an AC voltmeter. Voltage is measured as volts. The unit of voltage is volts, right? And AC indication is by this line. And this voltmeter is of the range 0 to 500 volts. And then this voltmeter has 2 terminals. In AC, the polarity of the leads do not matter because the polarity keeps changing for every frequency. Now, coming to the loads, as seen in the circuit diagram, we know that every load will have a start and a finish. So this is the start of our SR, and this is the finish of our FR. And then we have start of Y, finish of Y, start of B, finish of B. Each load is indicated with 2 bulbs in series, right? So we know that after SR we have an ammeter here, right? So we have also have the provision for ammeter connection here. So SR, ammeter, lamp 1, lamp 2. So SR, one terminal will be connected here. This is ammeter, and then lamp 1, lamp 2, and then finish. Similarly, this and this load. Now let us learn to connect the circuit practically. In the circuit diagram, from R phase, we have an internal connection to TPST. So from TPST and R phase, we have the extension coming out from this end, right? From here, it is connected to one end of ammeter. So let us take one ammeter, AC ammeter, which comes with 2 leads, right? For this, one end of this is connected to R terminal, and the other end of this is connected to another SR, the start of SR. So the other terminal will come to SR. Then from SR we have an internal connection here indicated with the white line. Then we have another ammeter which is connected here. So another ammeter which has 2 leads is connected at these 2 points. After this, lamp 1 and lamp 2 is connected, and we have the point FR, FY and FB connected at this point. This is the neutral point. So let us take a wire. So from FR, we have a wire connected to FY, and from FB, we can connect to either of these points, either here or here. Next, we finished the connection here. that is the point neutral is formed, then L3, L4, and then we have from SR to Y. So this SY, we have SY to Y. So this is SY terminal. From SY we connect it to Y terminal again. Now, we also have connected FB to the neutral, isn't it? Now, the other end of FB is SB. SB is connected to B terminal, blue terminal, the input of B. So, from SB, it is connected to B terminal. Now, we have to connect the voltmeter VL across R and Y terminal. So, this is R and Y. We take a voltmeter and connect it across R and Y terminals. Next, we need another voltmeter across SR and FR. So this is the voltmeter. We can connect it across any of the phases. As we have indicated it across the B phase here, we will be connecting across the start of B and finish of B. So now let us learn which measuring instrument is reading what. So this voltmeter is connected across SR, SB and FB. This is reading V phase, the voltage across phase. Next, we have this voltmeter which is connected across the line supply R and Y. So this is reading voltage VL. Then we have an ammeter which is connected from the line to the phase. So here we have one ammeter where it was connected, one end is connected to R phase and the other end is connected to red phase, the red input supply. So this is reading IL, the line current. And then we have another ammeter which is connected here to measure the phase current, right? So this measures I phase, right? So now let us switch on the circuit and see the readings of the experiment. Now you can see in a star connected load, the bulbs are glowing very beautifully, and observe the voltage reading. VL is reading 419, V phase 238, then we have IL and I phase, IL reading 0.19, IL reading 0.18, I phase reading 0.19 to 0.2, VL and V phase, right? Now let us tabulate the readings. Let's switch off the circuit. As we saw the readings in the meters, the I phase was indicating 0.18 amperes, V phase was indicating 238 volts, IL was indicating 0.2 amperes and VL was indicating 419 volts. We have to replace the values in this formula and cross verify whether we get VL is equal to √3 V phase, and since we have the readings almost close to that, we say IL and I phase, you can see that they are almost close. So IL is approximately equal to I phase, and hence we have verified the star connected load, the relationship between the voltages and currents of the line and phase voltages and currents in a star connected load. Now this ends the experiment for star connected load part. Now let us start with delta connected load. In delta connection, we see that they form a closed loop. Now let us see how to conduct this experiment practically. Now let us learn how to connect a delta connected circuit practically. So this is a delta in a three-phase connected load, and in this, if you can see, SR is connected to FY, FB is connected to SY, and SB is connected to SR. Let us start with SR. SR is connected to, so these are the three-phase loads, isn't it? So from SR, we have it connected to FY. So it gets connected to FY. Next, FY and SY are internally connected. From SY, it is connected to FB. So from SY, it is connected to FB. Now, FB and SB are internally connected. That is what we can see here. Now from SB, we have a line that comes to FR. So SB to FR. So in a delta connection, always make note that dissimilar ends are meeting at a point. I can also indicate this with color changes. So as said, I have just indicated it with a color difference here to make the understanding easy. SR is connected to FY, one line. Then SY is connected to FB, one line. And SB is connected to FR, right? Whereas I told SB and FB are internally connected. So we have a wire that goes beneath the board here, right? So this is delta connection is ready, but I have yet not connected the ammeter here. So let us finish up completing the circuit from one end and hence complete the whole circuit. Now from R, the TPST is connected, and the other end of TPST, it is connected to an ammeter. So ammeter, one end of this ammeter is connected to R, and the other end is connected to the point where FY and SR meet. That is this point. Right? And then after this, I have an ammeter here. So I take another ammeter and connect it in these points where we have the provision to measure the phase current. And then the delta connection is already done. We also checked it. Then from Y, we have a terminal that comes to SY and FB point. From Y, it will come to SY and FB point. So I take another wire from Y to the point Y where SY and now from the B terminal after the TPST, we have the line that comes till SB and FR point. So I take another wire from B terminal to the point where FB and SB and FR meet. So this is the point. So this is connected. So we have connected two ammeters and the circuit. We are yet to connect the voltmeters here. Now, one voltmeter, we have it across the points R and Y, isn't it? So one terminal of the voltmeter will go to the R phase, the other terminal of the voltmeter goes to Y phase. So let us connect the voltmeter now. One terminal, so two terminals. One goes to R phase and the other goes to Y phase. Remember, in AC, the polarities do not matter much. So you can connect without any worries, because they keep changing the polarities in every cycle. Then we have another voltmeter as indicated in the circuit. Another voltmeter is connected in the B load, isn't it, between SB and FB. So this is the B phase and we are connecting a voltmeter across these 2 points. So one terminal here and the other terminal to the point FB. Right? So this completes the circuit. Now let us understand which meter is reading what reading. This voltmeter is connected to measure the phase voltage, hence VPH. So this voltmeter is measuring VPH. Then we have another voltmeter here measuring the line voltages. So this is VL, this is VL. And then we have an ammeter. So this is the ammeter which is connected here. This is meant for measuring the phase current. And then we have another ammeter here which is meant to measure the line current. And hence this reads IL. IL, IPH, VL, VPH. Right? Now let us switch on the circuit and see the performance of the circuit. So you can see that in delta connection, the bulbs glow much brighter when compared to the star connected load. And also notice the current intake that it takes is much higher when compared to star connected load. So IL is reading 0.37, I phase is reading 0.24, VL is reading 420 volts, and then V phase is reading 419 to 421, we can take an average of 420 volts. I repeat, IL is reading 0.38 amperes, I phase is reading 0.24 amperes, VL is reading 422 volts, and V phase is reading 422 volts. Alright, so let us switch off the circuit and tabulate the results. Krishna. Recording the meter readings that we just saw while conducting the experiment. I phase read 0.24 amperes, V phase 421 volts, IL 0.38 amperes and VL 419 volts. Now, theoretically replacing the values here, we will have to cross verify whether these values match the theoretical calculation. Right? So we can see approximately VL and V phase are more or less similar. So IL is equal to √3 IPH. You will have to substitute the values and cross verify whether they also come approximately close to each other. So this is about the experiment, star connected load and delta connected load. And hope you understood. Thank you for watching.